we have to take a step back just for a minute and think about, you know, bonding. All right, just think about bonding, what we know about bonding. Bonding is all about electrons, remember? And so far, we've talked about ionic bonding and covalent, all right? And in the case of the covalent bond, say, for example, in methane, that's a molecule we're pretty familiar with by now. I just drew the Lewis structure of methane, showing the pairs of electrons that are being shared between the individual atoms in the molecule. And in this case, this is a discrete molecule. The electrons are being shared between two nuclei in each case. So we know the electrons are always moving. They're not really static, like stuck right there. This is just a model, of course. But we know that they spend the majority of their time, the electrons that is, between these two atoms and between these two atoms. So they're pretty localized. And then with the ionic bonding, remember, so the classic example is sodium chloride. And we know that what's happened here is that the electron that was in the valence shell for the sodium has been donated to the valence shell of the chlorine. And so now we have chloride with a negative charge. But this is discrete and this is discrete. The electrons are, you know, that are down in this sodium are pretty much localized around the sodium. The extra electron is hanging out in the shell of the chloride here. And then it's this very strong electrostatic force between this species and that species holding that together. Okay, the third classic type of bonding that we haven't spent a lot of time talking about is metallic bonding. And think about metals and what you know about metals. Metals, what we say is that the metallic bonding is the type of bonding that occurs in pure metals or metal alloys. And for example, what we say is that there's the atoms of the metal, whatever the metal may be, pretend like it's copper, for example, or yeah, copper is a good one. Just think about copper. And these dots that I'm drawing are the atoms of copper and the interior electrons of all the copper. And then what we say is that these atoms exist in a sea of electrons. Okay? The electrons on the valence shell of metals are very loosely held to the metal, such that they can move around excuse me, very easily from metal to metal. So, you know, the elemental copper, as all metals, is neutral. There's no charge, but when the electrons are kind of moving around from location to location amongst these metal atoms, at the instant that the electron kind of moves away from this one, instantaneously there might be just a little bit of a positive charge, and then another electron is going to move next to it, and et cetera, et cetera, et cetera. The electrons are kind of moving all around, but in no specific direction. They're just moving from place to place. That's why we see the properties of metals, or this is how we explain, I should say, the properties of metals, that metals are good conductors of electricity. If you can apply a potential difference across a metal, say a copper wire, then the electrons will move in a certain direction. And so we say they're conducting electricity. So this electron will move, bounce this one along, and move and bounce this one along, and bounce this one along, and bounce this one along, because there's a direction to it. Otherwise, they're just moving randomly. Metals are malleable. That means you can hammer them into thin sheets. And if you think about it, if the atoms or the electrons are sort of loosely being held, then the atoms are just being pounded and repositioned among what sometimes is described as almost like a fluid, like the electrons are almost acting like a fluid. They aren't, but that's the model that you can put in your head. And ductile, meaning you can draw them into a wire, so you can pull these atoms away from each other, and the electrons all just kind of rearrange themselves. So anyway, that's the unique property of metals. And so when we're thinking about metals, we're thinking about a sea of electrons that can kind of be convinced to move one direction or another selectively.